Imagine standing at the edge of a dark, still lake at midnight. You pick up a smooth, flat stone and skip it across the water. You watch it skip once, twice, three times until it sinks into the blackness. Now, imagine walking around to the other side of that lake and seeing ripples on the surface. You didn't see the stone hit the water, but you know with absolute certainty that something must have caused them. This is the story of our universe. We are standing on one shore, looking at the ripples, the galaxies flying apart, and the faint echo of radiation, the very structure of space and time. And we are asking, what was the stone? But what if the most disturbing possibility isn't that we can't see the stone, but that the lake itself didn't exist until the ripples began? Let's sit with that discomfort for a moment. We spend our lives anchored to a simple, almost instinctive rule. Everything has a beginning. Your morning started when your alarm clock went off. That clock began its life in a factory. The materials in that factory were forged in stars billions of years ago. We trace the breadcrumbs back step by step, cause by cause. And we feel a profound sense of security in this chain. It tells us we are connected to the past, that our existence is the logical linear result of everything that came before. It's the most natural thought in the world. So when we point our telescopes at the night sky and see the universe expanding, our instinct is to run the film backwards. If it's getting bigger now, it must have been smaller yesterday, and smaller still last year, and infinitely smaller a billion years ago. We wind the clock back and back until the entire universe, every galaxy, every star, every atom is crushed into a point of infinite density and infinite temperature, a singularity. We call this the Big Bang, and for decades that was the story. The beginning, the primal atom, the moment when time itself began. But here's the catch, and this is where our intuition starts to break like a skipping record. When we say the beginning of the universe, what are we actually picturing? Most of us, if we're honest, picture a dark, empty, infinite void, a vast nothingness, and then in a flash of light, a tiny hot speck of something appears in the middle of that void and explodes, filling the emptiness with matter. That image is so powerful, so cinematic, that it has become the default mental model for the Big Bang. It feels comfortable because it follows the rule. There was a void, then there was an event, and now there is a universe. But that image is completely, utterly wrong. It is the single greatest misconception about the origin of everything. Because the Big Bang wasn't an explosion in space, it was an explosion of space. There was no pre-existing void, no dark, empty stage waiting for the lights to come up. The stage itself was part of the play. So when you try to run the film back to that moment of beginning, you aren't just compressing matter into a tiny ball. You are compressing the very fabric of reality, space, and time themselves into nothing. And this is where our language fails us and our intuition screams in protest, because asking what happened before the Big Bang is like asking what is north of the North Pole. And if the question doesn't sound wrong at first, but if you think about it, you realize the question itself is the problem. The North Pole is the point where every direction is south. There is no north of north. The Big Bang in this stark view is the ultimate North Pole of existence. It's the point where the very concept of before ceases to have meaning because time itself was a structure that began there. And yet we can't leave it there, can we? That answer, while mathematically tidy, feels like a trap. It feels like we've just drawn a line in the sand and said, curiosity ends here. That's not how science works. That's not how we work. If you tell a child that the universe began 13.8 billion years ago, the first thing they will ask is, but what was God doing before that? Or where did the stuff come from? It's the most natural human question in the world. And to simply say there was no before is like giving them a philosophical brick wall to run into. It doesn't satisfy the curiosity. It just frustrates it. It shuts down the wonder. And in shutting down that question, we might be shutting the door on a deeper understanding of reality. So let's do what Feynman would do. Let's stop trying to answer the question with a definitive statement. Instead, let's play. Let's take the question seriously like a curious child and see where our imagination, guided by the strange rules of physics, can take us. Let's hold the brick wall in our hands and look for the hidden doors. What if the beginning is a mirage? What if our linear way of thinking, this thing, then that thing, then that thing, is just a useful shortcut? for dealing with coffee cups and falling apples, but completely breaks down when we try to apply it to the cosmos as a whole. To get a grip on this, we have to descend into the basement of reality. We have to talk about what space and time actually are. To you and me, space is just emptiness, the stuff between things. It's nothing. But physics tells us something far stranger. Space is a thing. It has a structure. It can be bent, stretched, and warped by mass and energy. Einstein spent a decade of his life figuring this out, and what he gave us was a vision of the universe where gravity isn't a mysterious force pulling across empty distances. Gravity is the shape of space itself. A planet doesn't orbit the sun because it's being pulled by an invisible rope. It's orbiting because the sun has created a dip in the fabric of space, and the planet is simply rolling around the inside of that dip like a marble rolling around inside a funnel. This is the first key to unlocking our question. If space is a dynamic, flexible fabric, then the Big Bang isn't the moment a bomb went off. It's the moment the fabric started stretching. And when you stretch a fabric, interesting things happen. Tiny quantum ripples, imperfections that are normally invisible, can get stretched into enormous structures. This is precisely what we think happened in the first infinite decimal fraction of a second after the expansion began, a period called inflation. The universe expanded faster than the speed of light. And yes, that's allowed because it's space itself expanding, not objects moving through space. It took quantum fluctuations, microscopic jitters in the fabric of reality smaller than an atom, and stretched them into the seeds of galaxies. The patterns we see in the cosmic microwave background, the afterglow of the Big Bang, are literally those quantum jitters frozen in time and magnified to cosmic scale. The largest structures in the universe, the great walls of galaxies stretching hundreds of millions of light years, were once quantum foam. The universe, it seems, is a memory of its own quantum past. But let's push further. If space can stretch and curve, what happens when we push this idea to its breaking point? What about the matter itself? We're made of atoms. Atoms are made of particles. And particles, in the most modern view, are not tiny little billiard balls. They are excitations in fields. There is an electron field that permeates all of space. What we call an electron is just a localized vibration in that field, like a note plucked on a guitar string. The universe isn't filled with particles. It's filled with fields, and particles are just the music those fields make. This is a crucial shift in perspective. Before the Big Bang, or at its very moment, perhaps the fields were there, but they were silent. No vibrations, no music, no particles, just a perfectly still, featureless ocean of potential. Then something happened. A change in the energy state, a phase transition, and the fields began to vibrate. The universe, in a sense, didn't appear from nothing. It rang into existence. Now, we're getting closer to the heart of the mystery because this idea of ringing into existence opens up a terrifying and beautiful possibility. If the universe began as a quantum vibration, then the rules of the quantum world apply. And the quantum world is a place where our common sense goes to die. In the quantum world, things don't have definite properties until they are measured. A particle doesn't have a fixed position. It exists as a cloud of probability, a ghost of potential in many places at once. It only chooses a location when it interacts with something else. Cause and effect get blurry. Particles can pop into existence from pure energy and disappear just as quickly, as long as they do it within a time limit set by Heisenberg's uncertainty principle. It's a frothing, bubbling, unpredictable reality. So if the universe began as a quantum event, then the very idea of a first cause becomes fuzzy. It suggests that the origin might not have been a single decisive moment, but a quantum jump from a state of no universe to a state of universe. And in the quantum world, such jumps don't require a trigger in the way a mouse trap requires a finger. They are inherently random, uncaused events. The universe, in this view, might be the ultimate uncaused event. The stone that started the ripples wasn't thrown by anyone. It's simply quantum tunneled into existence. This is where we have to summon our courage and confront the most unnerving door in the brick wall. the concept of time itself. We experience time as an arrow. It flows in one direction from past to future. We remember the past. We anticipate the future. This is so fundamental to our existence that we assume it's a fundamental property of the universe. But physics suggests otherwise. The laws of physics at their deepest level don't have an arrow. They work just as well forwards as they do backwards. If you filmed a single particle interacting with another and played the film in reverse, the physics would still be perfectly valid. So where does our sense of the flow of time come from? The most compelling answer is that it comes from the Big Bang itself. The universe began in an incredibly ordered, low entropy state. Entropy is a measure of disorder. And the second law of thermodynamics says that disorder always increases. An egg unscrambles, it doesn't unscramble. This one-way street of increasing disorder from the perfect order of the early universe to the eventual heat death of everything is what gives us the arrow of time. We are surfing the wave of increasing entropy that started at the Big Bang. This is a profound realization. It means the Big Bang isn't just the beginning of matter and space, it is the beginning of causality itself. It's the reason we can even ask the question, what came before? Because the very structure of cause and effect, the logical chain that our minds are built to navigate, is a consequence of that initial event. We are using a tool, logic, that was forged in the fire of the Big Bang to try and examine the fire itself. It's like trying to use a ruler to measure itself. So where does that leave us? Standing on the shore of that dark lake, looking at the ripples, haunted by the question of the stone, we've played with the ideas. We've imagined quantum gravity, vibrating fields, a universe that popped into existence like a phantom particle. We've considered the possibility that time itself is a local phenomenon, a kind of emergent property, and that before the Big Bang is a grammatical illusion. And maybe that's the most honest answer we can give right now. We don't know. The phrase "I don't know" is the most powerful and beautiful phrase in science. It's not a surrender. It's a declaration of a frontier. It's an invitation. But let's end with one final thought experiment, one that might leave you with a different kind of chill. Imagine for a moment that the universe is not a single event, but a cycle. Imagine it expands, cools, and eventually the stars burn out. The universe becomes a dark, cold, diffuse sea of elementary particles and radiation. In this distant future, space is almost empty, and the energy density is unimaginably low. In such a state, the quantum rules become dominant again. Fluctuations become relatively large. It's possible that in this timeless dark void, a quantum fluctuation could trigger a new event of inflation, a new Big Bang in a tiny patch of space. Our entire universe, with its 100 billion galaxies, might be just a bubble in a foam of eternally inflating space. One cosmic spring and an endless quantum winter. And within that bubble, time begins again. The new universe has its own arrow, its own past, its own future, completely disconnected from the parent universe that spawned it. The question, what happened before our Big Bang, would have an answer. The cold, dead universe that came before. But to any beings inside that new universe, that answer would be forever inaccessible because the connection would be severed. The information would be lost. This is the truly haunting part. It's not just that we don't have the data yet. It's that the nature of reality may have a built-in horizon, a veil beyond which we can never see. The very event that gave us the gift of existence, that lit the fuse of cause and effect, may have forever erased its own origins. The stone that started the ripples may have been swallowed by the very lake it created. We are here complex, conscious beings, capable of contemplating the stars, of tracing our lineage back to that primal fire, only to find that the trail leads not to a door, but to a mirror. We are looking at the ripples, and the ripples are us. We are the universe's way of asking the question of its own beginning. And perhaps in that asking, in that profound and eternal mystery, we have already found our found answer. We are the children of an event that has no parent. We are the dream of a quantum fluctuation. And the silence that greets our deepest question is not an emptiness, but the sound of our own existence echoing back from the beginning of